Good morning. Welcome to Sunday Science Q&A, or Shambles Science Q&A, or Science Shambles Q&A, whatever you want to call it. We've known each other for a long time now. Today we're going to be specifically talking about COVID. We haven't done a COVID special for a while, and obviously there continues to be lots of information going out there, some of it more useful than others, some of it more reliable than other information as well. So if you have any questions that you would like to ask, we've already had a load sent in over the last 24 hours, but as this is a live show as well, if you send them either to @CosmicShambles or you can pop it in the chat, then we will ask our experts who are today, as well as Helen Czerski, who's always an expert and always with us. We also have Professor Sheena Cruickshank, and we also have Dr. Christina Pagel as well. And so we're going to be dealing with lots. So just a couple of things. Patreon plug. That's what I always do at some point in this, and that is if you can support us via Patreon, that is fantastic. That is how we make all the shows that we make, and we normally have 4 or 5 shows going out a week. Sometimes that goes up and down depending on what other people are doing, but we are still putting out a lot of stuff, including a new series of Dean Bennett and Rachel England's brain yapping as well. So if you can support us via Patreon, then go to patreon.com/CosmicShambles, and that helps us. We have started working on a new series of An Uncanny Hour, and we've also got a brand new series called A Book You Might Not Know. And this week, Tips for Existence is Carolyn Porco talking about many different things, from 2001: A Space Odyssey to the Cassini mission, and ideas of extraterrestrial life and the fact that there is no planet B as well. Other things to tell you as well is the tickets are now on sale for, we are going to actually do in a room with a live audience. Even though we did have a little bit of a live audience when we did our 25-hour live show last Christmas, we are doing a proper full-on version of 9 lessons and carols for curious people in London. That's on December the 10th, 11th, 17th and 18th. Go and have a look at our website. We've got a huge number of people doing those shows. That's at King's Place. I apologise for the fact we were going to be doing some other parts of the country as well, as we promised and as we have sometimes done as well, but just with the way everything is, it was been a little bit overly difficult to actually get that sorted, and we will try and put up bits and pieces online as well and do backstage interviews and all of those things. That's pretty much all you need to know. Also, I saw my book for the first time in a live bookshop yesterday. I was at the How the Light Gets In festival at Kenwood House, and so I will start plugging that mercilessly now. My importance of being interested is out on the 7th of October. I'm doing 109 bookshops over 2 months, doing talks at all of them across the UK. So you can, if you can, go on the Cosmic Shambles site /100 bookshops, and you'll find out all about those. Good morning, Helen Czerski.
How am I? I ate this morning. So and this is relevant.
Morning, and sometimes I presume it's because it's the same. It's like when you have the vaccine and you go, oh, I feel all tired today, and then you go, yeah, I'm 52. I always feel tired.
Well, I have a very specific excuse, which is that there is a race in Scotland called Monster the Loch, which is a paddling race the length of Loch Ness. And I'm up here with my paddling club. We did that yesterday. And so 3 hours and 20 minutes. Loch Ness is a long race. And this is relevant to the science I'm going to talk about. But Trent's got a couple of photos here of the outrigger at the start of the race, just looking down Loch Ness. We were so lucky. It was a beautiful day. And to be looking all the way down the loch at the start was amazing. But even better was the medal at the finish. And they had a piper, of course. Piping is in at the finish. You can see it in the medal. So it was a very, very long day out in the canoe. But so I thought I would talk about a bit of science relevant to Loch Ness, because obviously, although we were looking for the monster, we did not see the monster. We just saw the bagpiper quite a lot. I'm starting to suspect that all this stuff about Loch Ness monsters, it might just have been a bagpiper that was underwater somewhere. Anyway, but a couple of years ago, a load of scientists released a study. New Zealand scientists came and they took environmental DNA samples from Loch Ness. So it's really a really interesting study. They took water samples from all over the loch, different depths, and I think it's the largest body of water because it's 220 meters deep or something. It was 21 miles long, as I know very precisely. So they took these different water samples, and the thing about DNA, like, it's really hard to appreciate just how small it is. Like, really, it's about how big we are compared with molecules. Like, we are enormous compared to the molecule. But what you can do, because DNA is both so small and it kind of sheds, bits come off animals. So bits of skin come off, they poo, obviously the poo was going to come into it, you know, they break things off that, you know, maybe their teeth fall out or something. There's loads of bits of DNA that can get into the water. And because these molecules are so small, even in a relatively small water sample, the loch is carrying the DNA of the things that live in it. And so what they did was they looked at the DNA in these 250 different places, and they could see the evidence of animals. So they could see mammals that lived on the side of the loch. They could see the DNA from fish that lived in the loch. They did not see any plesiosaur DNA or any reptile DNA. They didn't see any sharks. They ruled out quite a lot of there's quite a lot of things that are not Nessie, and they did find a lot of eel DNA. So the most charitable explanation for the people who really want to believe in the Nessie is that it might be quite a large eel, because there are clearly a lot of eels in there. But it's just it was a really nice way. I mean, nobody likes it when scientists come along and they poke a pin in everyone's favourite idea of the Loch Ness Monster. But this is really interesting because it just gives you a broad picture of what is in the lake overall. And I thought it's really interesting because we're talking about COVID today, because of course people have been using this environmental DNA technique to look in wastewater for evidence of COVID. So I just thought it was a nice comparison of techniques, that with this one scientific trick you can both look for what the Loch Ness Monster might be, and you can look for what diseases there might be in the human population. So that's my show and tell for this week.
Well, of course, as usual, science was looking for entirely the wrong thing. So that's got Loch Ness Monster, what you just said. The most recent idea of the Loch Ness Monster is in fact the ghost of a dinosaur. So you will have to use different techniques if you're going to try and find that. That is, in fact, I think I talk about that. I mentioned books that are out. I've written the foreword to the Usborne Book of Monsters from the World of Unknown series, which comes out, and that is one of my favourite ideas. The idea that it's the ghost of a dinosaur, I think, is a beautiful, especially when you see those wonderful shadowy. Some of them clearly faked. Some of them, now with the technology we have, some of them, I think, merely those kind of moments of shadows or activity which we place the pattern of it happening to be a giant monster on.
Well, I wonder what ghost DNA looks like. That's another whole thing, isn't it? But it is, I mean, Scotland can be quite a grey place, and you do, you know, from being at sea, if you're on a ship and you stare at grey ocean for days and days and days, it takes about 3 weeks, and then you do start seeing shapes because your brain just wants something. You just want something to be there. So if it was a very misty and grey, I can see that people might see things. Anyway, so I'll go and ask the local. The locals are so keen to talk about the Loch Ness Monster, and we were shown a haunted house yesterday. We didn't want to be, but someone pointed it out on the way past. So maybe that's where.
Yeah, it's very possible. There's still a lot of work to be done there, obviously, but we might hold off for a while on that. Christina, good morning. I called you doctor, and I think you're professor, aren't you?
Yeah, I am. That's right. I can get demoted on a Sunday.
Are you still doctor on Twitter? Is it one of those ones like Alice Roberts who went, I can't fit my new title into my Twitter name?
No, I don't think so.
Well, I apologise for demoting you. I've now placed you back where you are meant to be. Now, can I ask you, have you got a show for us this morning?
I do, but just before that, I had the Usborne Book of Vampires and Werewolves as a child, and I absolutely loved it. They're the best books.
Those illustrations, I've still got that little anthology which is I think Ghosts and Hauntings, Vampires, Werewolves, and there's one other one in that. And those one of my favourites is the kind of it's not a werewolf, it's a were-elephant. I don't know if you remember.
Yeah, no,
one.
I do. I do. And there was also kind of a strange Japanese that I remember being really interested in. Yeah, but
clearly we have to do science
and Borley Rectory as well, of course.
Monsters.
Right. Anyway, so my show is this, which is a Voyager belt buckle, and it got the Voyager launch date on the back, and it was cast in 1977 with the launch of the Voyager 1-2 spacecraft, and was given to the scientists on it, and one of them was the boss of my husband, and then he gave him this belt buckle when he left MIT 15 years ago now. And the Voyager spacecraft are just, I think, one of the greatest achievements of man ever. So I'm going to give you just a really quick potted history. So they were launched in 1977, two exactly the same spacecraft, that kind of duplication of effort that we just would never be able to fund now. And they were done to take advantage of the fact that all the planets were aligned. So they went on a tour of the solar system. So they visited, Jupiter, Saturn, and then Voyager 2 was the first spacecraft to visit Uranus and Neptune, and they'd never seen it before. And Al Lazarus, who was lead of the magnetic field instrument, said that they were all waiting around this dot matrix color printer, and it sent the first pictures back, kind of dot by dot, and they were watching it come. And this is one of the pictures of Neptune that Voyager 2 took, the kind of pale blue gas giant. And it was discovered, the magnetic field around Uranus, it discovered 10 new moons there, it discovered 6 new moons at Neptune, discovered rings of Neptune. I mean, it was just incredible. And then they just carried on out of the solar system. So the Earth has got a magnetic field around it, which protects us from the solar particles and what's called the solar wind. And then the solar system has exactly the same thing. So there's an area around the sun where everything in it basically comes from the sun. All the particles come from the sun. That's the solar wind. And outside that is interstellar space. And so the Voyagers carried on. And the idea was eventually they would go out of interstellar space. Now the sun's moving through the galaxy. And so that sphere, the magnetic field around it, is kind of like a nose-shaped cone. And they went out the front. They went out the nose because that's the shortest way out. And so in 2012, Voyager 1 was the first ever spacecraft to leave the solar system. It was 23 billion kilometers away, so 150 times further away from the sun than the Earth is. And it went kind of north, so the planets are all on an ecliptic in a single plane, and it went north out of it. Voyager 2 went south, and it crossed into interstellar space in 2018. So we now have 2 working spacecraft out in interstellar space, and they still work. 50 years, almost 50 years later, they're still finding things. Just last year, there was a new paper published showing that once they went into interstellar space, space got denser. So there are more particles per cubic centimetre outside than just inside. And that was completely unexpected, and people don't really know why. I mean, there's still not really much there, but that's still there. And this is happening with technology from the 1970s. It's got now it's powered by plutonium. It's got about 20 watts of power, so like a third of an old light bulb, and it's sending data back to Earth. And the only way they can pick it up is they use what's called the Deep Space Network, which are 3 massive dishes, like one in Australia, one in Spain, and one in the US. And it hasn't got enough power. It doesn't have any memory left. It used to record things on tape. That's all broken. So you can only get data from Voyager if you're looking at it. And so the Deep Space Network's used for all kinds of things. So now they can't look at it that often. And when they do look, they get the data back from the Voyagers. But slowly that plutonium is now running out, and they're shutting down the instruments one by one. The first thing they shut down was the camera. And they did that 30 years ago, because after the orbit of Pluto, there's really nothing to see. It's just black. And just before they shut down the camera on Voyager 1, they turned it round to look at Earth, and they took a picture of Earth from 40 astronomical units, so 40 times the distance that we are from the Earth. And that was what Carl Sagan's idea, and that was the famous pale blue dot picture. This is the Earth from the edge of the solar system. But now they're turning off more and more, and in 2025, that's it. Not enough power anymore. You can't have, it doesn't have solar arrays, but even if it did, it's far too far away to get any energy from that. But the Voyagers will keep going. So they worked out in 40,000 years, both of them will be within about 2 light years of a star. Voyager 1, it's called Gliese 445, and Voyager 2, another star called Ross 245. And then in 300,000 years, Voyager 2 will be close to Sirius, which is the brightest star in the night sky, but only within 5 light years. And they're not expected to really ever hit another star. So they're just going to keep going forever, long after our solar system is gone. And I just think that's amazing. That's a piece of what we've built that's going to effectively last forever. And both of them carry a 12-inch gold disc that has, pictures of Earth, sounds of Earth, instructions of how to play it. It's got a location of Earth. It's got a message of peace from the Secretary of the UN. And that is out there forever. And I think that's pretty cool.
We should mention that the message of peace from the Secretary of the UN, it was Kurt Waldheim, who later turned out to have been a Nazi.
Really?
So,
Oh,
yeah,
yes.
looking back, you know,
Don't
we
spoil
go,
it.
oh, trust that. No, but I think that in itself has, because it's such the golden disc, and you can download it and stuff, and you can hear it. We used to use it as walk-in music for audiences and you could hear them going, "What is this?" Because you hear, you know, there was a lot of argument about the music, because obviously some of the people wanted it all to be American music and where's Frank Sinatra, and of course it had music from around the world of so many different cultures. But yeah, I love that little Kurt Waldheim detail of just going, right, we've sent it out into space. There we go. What's that about Kurt Waldheim? Oh, Fab, why didn't someone research that? But I mean, it was a big reveal at the time.
Never
Oh,
look
no,
at your
there is just one more really cool thing about it. So on the magnetic field instrument, at the base plate of it, which is in metal, they engraved the signatures of all the scientists. So they're out there.
I mean, I totally agree with you. Sorry, Helen.
I was going to say, Christina, I have to ask, because behind you we can see a map, what it looks like a star map and a globe with stars on. And of course, you're not known for your astrophysics. Do you have a background in this? So have you switched fields, or is this just?
Yeah, I switched fields. I did my PhD in space physics, and then I did a postdoc in space physics. That is just the Earth, but it's just black. That is the Hubble Deep Space Field, which I just love that picture. And every dot on there is a galaxy. And you know, if you think there are 100 billion stars in our galaxy, and you know, billions of galaxies, I just look at that and you just think, wow. No,
it is. There's so much more we could talk about this, and we would. In fact, let's do another one on this. We'll do this another. Sheena, good morning.
Morning.
Now, go on.
I also read the Osborne books as well. Beautiful what Christina was talking about. I had the book on haunting, ghosts and haunting, and I think I had the monsters book as well. But some of them were real things, if I recall rightly.
That's right. Yeah. Some of it's a really nice, but it's interesting, isn't it? It's nice to talk, you know, to scientists, many of whom were inspired by those books. It didn't matter that a lot of what is in there is myth and sometimes nonsense, you know, sometimes beyond even myth, because it just shows curiosity, doesn't it? It was that bit of poring over all those pictures going, but imagine if that thing did exist, and imagine if, and it doesn't mean by imagining that you therefore immediately take a path down to then irrationality, that somewhere within the rationality and irrationality is a wonderful place of curiosity as well.
Definitely. I tried to pass it on to the kids, but they were having none of it. They were like, what's this?
Yeah, I think we have a new video games have changed everything. Kids. What is your show and tell today?
My show and tell is kind of going down to, I guess, more the microscopic. I am doing a show and tell on the antibody, because everybody is talking about antibodies now and antibody levels waning. And I just want to get back to the kind of marvel of what antibodies have been able to tell us. So they were discovered, I think, or the term antibody, I think, was first coined in 1891 by Paul Ehrlich. And since the discovery and kind of working out all the amazing things they do in the body, their ability to bind to unique features of germs or cells or anything really, and to make lots and lots of copies of this antibody clone. So you get a clone, you get loads and loads of copies of it. And, you know, and in terms of infection, we know that can stop germs getting into cells. It can help flag cells for destruction in lots of different ways. Lots of different immune cells can then do that, and it can help clear things from the body. What is probably less well known is our ability to use antibodies for bringing forward science. And antibodies have actually been able to do all sorts of things for us. So because they have this unique feature of binding to a unique structure, and we can make lots and lots of copies of them, that means we can make them in the lab. So we've got lots of different ways now that we make antibodies. So very crudely, when it was initially done, what they used to do was they used to get something like a horse, and they used to inject it with some venom or something like that. And then they'd harvest some of the blood, and the antibodies, there'd be a real cocktail of different types of antibodies in there they would use. And that was antivenoms. And they also did the same for toxins. So some of the early therapies for snakes to protect against snake bites, spider bites, were done using this very, very crude technology, and also things like diphtheria toxin treatments. But we've got a bit more, I guess, technological since then, and we can actually make them artificially in the lab. We can also make them more pure. And this has enabled us to do things like define and understand all the cells in the human body, because we can look at discrete features of these cells and we can start to understand what they do. So even though they might look very similar down a microscope, we know that they have different functions. We know that they have different markers that let us tell what they do. So if you take T cells that everybody keeps talking about at the moment, they go, oh, T cells, aren't they a thing? Aren't they also important as well as the antibodies? There's lots of different types of T cells, and we know more about these T cells because of antibodies. They've enabled us to find out that we have some T cells that can kill viruses. We've got some T cells that can help B cells make antibodies. We've got some T cells that can help switch off immune responses. They're regulatory T cells. So they're really important at calming down an immune response when you've had it. We've even got specialized ones that can just help kind of reinforce all the barriers, all the sort of like your skin or your gut in an infection, called Th17s. So we learn a lot about these from antibodies. And the antibody technologies also let us do things like some of the COVID tests that we're doing. The lateral flow test that most people are doing is using antibody technology in your home. So you are basically using an antibody test. It's an antibody that's going to bind to that antigen in your body, which is, you know, when you take your little nasal swab, you might be picking up a little bit of protein from the virus. Well, and then that will bind to the antibody, and there'll be a color change if it's there. And the same principles used in a pregnancy test. You're looking for human chorionic gonadotrophin, which is quite difficult to say when you're slightly hungover. And we also use it in therapy as well. We've used it in COVID therapy. So some of the treatments for COVID are blocking particular disease molecules or particular immune molecules using antibodies. And some cancer therapies and arthritis therapies and therapies for inflammatory bowel disease all use antibodies to block particular effector cytokines and effector products that cause inflammation. So I think the antibody, all the way from 1891, when the term was first coined, has done so many remarkable things to bring forward science, to bring forward medicine. And it's something that we talk about and people don't even appreciate just how special they are. So there you go.
Thank you very much, Sheena. That's wonderful. Let's get now down to the. We've had so many questions on COVID on so many different kind of areas of this. Christina, I'll start with you. This is from Mr. Puddington or Puddington, who says making people pay for lateral flow tests seems a bad idea in principle, but were they ever accurate enough to be anything more than an illusionary crutch anyway?
Yeah, well, I mean, it's a good question. I don't think we should be making people pay for tests at all, because I think it kind of sends a slightly worrying message, and it also means that, you know, it has completely different effects depending on, say, areas of deprivation, whether you can afford to buy tests. Now, lateral flow tests are less accurate than PCR tests, which is kind of the gold standard, but the idea is that they are not that bad at picking up infection if you're currently infectious, if you have a high viral load. But the key thing is that they don't definitely mean you don't have COVID. But if you test positive, you almost certainly do have COVID. So in terms of if you don't have any symptoms and you don't know you're sick and you take a test, it's better than not taking anything, for sure. Because if you don't test yourself, right, you've got 100% false negative rate. So, and where they would be really useful is if you take them regularly. If you take them every few days, in theory, you should pick up an infection if you have it. Now, the problem with them is that a lot of people don't do them properly. If you don't get that swab really far up your nose for long enough, you're not going to pick it up, even if you're positive. And secondly, if you test positive, there's actually very little incentive for anyone to test positive if they feel fine, because it means your life gets completely disrupted, especially if you can't afford not to work or you have care responsibilities or whatever. So in that sense, because of how we're using them, it's not clear that people either do the tests or do them properly, or can do anything if they test positive. So that's kind of the limitation, but we can fix that. I mean, that's all fixable.
Could you just be clear about what doing the test properly is? Because I think that just mentioning that might have worried people a little bit. So could you, what's the key thing? I mean, I know this is, but is it just getting the stick far enough up your nose, or are there other things that people, to be sure?
Yeah, I mean, so it used to be that you had to take it from your throat and your nose, and now I think it's just your nose. But yeah, the key thing is to get it far enough up that you feel like you're about to sneeze, I think, and then to leave it in there long enough. And now it's both nostrils, and that should pick it up if the virus is currently in your nose. Now, if it's not there, it won't pick it up. But that's kind of what properly means. If you just kind of stick it up your nose for a couple of seconds, or you just swabbed your cheek or something, then it won't work. And the same is true for PCR tests, but you tend to do them under some kind of supervision, or when you have symptoms, so you're more interested in getting a positive test. That's why.
I think the other thing I've seen happening is people have an air bubble in the little solution when they add that interferes with the ability of the antibodies to bind. So that's another way that people can get it wrong. But you probably won't get the positive control strip, because you always get one strip that tells you that the test has worked in principle. So if that bit doesn't come up, you've definitely done the test wrong. You need to do it again.
Yeah, I've found I'm back on tour at the moment, and everyone involved in the tour, we do lateral flow every single day, just to be, because, and yeah, we're still taking a lot of, having been being self-employed, not really being able to work for 18 months, being really, really careful. Please, more people on London Underground, wear a mask. It's really simple. Yeah. That's all. I just cannot believe it. This is a question for you, Sheena, from Jay Campbell, who would like to know, why is Delta more vaccine resistant?
Yeah, so the other one that's more vaccine resistant is the beta strain. The way the vaccines work is they've kind of taken the part of the spike protein, which is the bit that's used to stick onto cells and gain entry into cells. So they make they kind of take a little sequence from that, so that we will make antibodies to that bit, and that will block the cells from going in. But what the antibodies see are discrete shapes, as it were, and sequences of the DNA that codes for that. And if you get certain changes in the sequence, that affects the ability of the antibodies to bind to that sequence. So you will get less effective binding or no binding at all, because it looks a little bit different. I mean, very, very crudely, if you think that it normally recognizes something like that has a sort of round shape, and you change the genetic code slightly, so now it's not round anymore, it's more of a sphere, the antibody just can't bind to it properly anymore. And so that means that the vaccine might not work as well, because we're basically making a vaccine that's designed for the parent strain and the alpha strain that it works really, really well to, but the virus has just changed its structure very, very, very slightly. Now, it's still working pretty well, actually, against the Delta variant. So that is quite good news, because there was a lot of concern when we were seeing the genetic structure of that particular variant come through, that we were going to see quite a lot of more issues with immune evasion, but it's not been quite as bad as we initially feared. So back in about February, was it about February? Was it as long ago as that? Can't have been as long ago as that. That's what we were all talking about, is the concern about that. But yeah, does that make sense? It's sort of antibodies not seeing things properly anymore.
Yeah, great. That's great. Thank you. And the next part is from John. John would like to know more about COVID now than we did 18 months ago. What for you is the most frustrating thing that is still being ignored? And John says for him, it's ventilation.
I mean, ventilation is a really big one. I mean, we've known it's airborne for over a year, and we know that, we've known that outdoors is so much safer than indoors. for a very long time, like, 20 times safer. And so the more fresh air you can have indoors, the safer it is. And we can do that. We know how to do that. And we just haven't invested in improving our ventilation in schools, in public buildings, in businesses. And, fresh air is good anyway. Like, even without COVID, that's a public health benefit. So I can't quite understand why we haven't done it, especially, as many buildings were shut for months on end during lockdowns. The other really frustrating thing for me is a refusal to learn from what other countries have experienced. It's like we are doing COVID on our own, and what's happening elsewhere just is not considered relevant, and it's just incredibly frustrating. So, like, the most recent thing being, it's inevitable that we have really high cases, it's Delta, there's nothing we can do, when other countries have Delta, high vaccination rates, and a little bit extra, and are actually coping with it pretty well. And have far fewer cases than we do, fewer deaths, fewer hospitalizations. So this kind of idea that why can't we learn from other countries, whether in Europe, Southeast Asia, or wherever they happen to be, is really frustrating.
And just perhaps provide some context on that, because I think one of the things is, so I think the public who are not involved in COVID, and me, I don't know, it sort of assumes that this information is somewhere. Is there a central way of sharing information? Like, how easy is it for you as a researcher in this area? Can you find these things out? Are countries sharing information? Like, how easy is it to know what's happening in other countries?
Masses of information. I mean, the European Centres for Disease Control runs COVID surveillance over Europe plus the UK. They have data on, cases, hospitalizations, deaths, vaccinations, and also just a situation alert and monitoring what interventions each country is doing. The WHO is really active in that. Countries do talk to each other. Most countries have publicly available data similar to us. Like, we have excellent data here. Other countries have that too. And researchers talk to each other. And there's loads of studies about different approaches, international studies, different approaches to different countries and how well they've worked. It is there. It is notable.
It is. I think it's very depressing to see the kind of celebration of ignorance and avoiding so many of these things. I think many people probably watching this were tremendously frustrated to see the fact that when the House of Commons was back in session and it was an absolutely packed House of Commons, almost all of the opposition were wearing masks and almost all of the Conservative Party were not wearing masks, which immediately sends out, it just right. So a question from Vaughan for you, Sheena. Was herd immunity ever really possible?
Well, I mean, to a degree, it depends. We are getting some degree of protection from vaccination and prior infection. So we are seeing good, robust immune memory from vaccination. That seems to be persisting. Well, we've still got evidence of the memory cells. So what your immune system does is it's got different parts of it that operate. So it takes a little while for your B cells to start making antibodies and your T cells to start helping them making antibodies and to start generating killer T cells that will kill the virus. But then when they know what they're supposed to do, a population of them are kept and retained, and these can really last lifelong. And so, for example, they've found evidence of memory cells from the flu pandemic in 1918. They can still see that 90 years later. So immune memory is truly remarkable. So we are seeing really good evidence of memory T cells and memory B cells. And we are seeing effector T cells that can quickly do things. They're persisting. So what that means is that for people who are having that good response is that they still seem to be well protected. And that bears up with what we're seeing from the hospital data, where we're seeing much fewer people who've been double vaccinated get severely ill or die, which is a good thing. But I'm not sure whether we can get 100% immunity from this, so absolute sterilizing immunity from this, and that's because I don't think our neutralizing antibodies are going to stay high enough to stop the virus sort of getting in and starting. And the big concern is just how much COVID is still around in the world. And, you know, most of the world doesn't have vaccines at all yet. You know, less than 5% in many countries have yet to be vaccinated. This lets the virus thrive. This lets more variants emerge. It's no coincidence that they come from places where there's been huge outbreaks of infection. So I think that is a worry, and that will make herd immunity or any kind of degree of herd immunity quite challenging. And of course, you've always got immunosuppressed people as well who never mount a particularly good immune response, unfortunately. So difficult one to answer. So there's shades of it, I think, perhaps, and problems around the corner. And I don't know if Christina wants to add anything else in terms of the global picture, because I know you've talked a lot about that.
Yeah, I mean, I think from an individual country point of view, with Alpha, we were a lot closer. So Israel kind of got there with almost 0 cases before Delta came along. But Delta is so much more infectious and is a little bit more immune evasive that it means getting to a stage where enough people are immune that it will never spread seems quite unlikely. So that means that we really do have to actually just vaccinate as many people as we can. And that means everywhere, you know, like Sheena says, and also particularly vulnerable populations. So the US currently is recording, you know, almost 3,000 deaths a day again, 5 months after vaccines have been available to every single adult. And what's happened there is that they have far fewer adults than we do vaccinated who are over 50. I mean, they've got like 70%, 75%, and we're at, you know, well over 90%. And it means that even they just have so many more vulnerable people, and that's causing a lot of problems. And that is where we have to do it. And then, you know, as Sheena said, many low-income countries are less than 5% of their population have been vaccinated.
And I guess in the States, it's very patchy as well. So there's some areas in the States where there's very, very low vaccine coverage. Indeed, there's a lot of vaccine hesitancy and anti-vax sentiment. And that also gives you this sort of uneven distribution. So whereas it sounds like it's not bad with 70-75%, it's really, really patchy. And I've got colleagues working in places like Texas who are just so frustrated.
And it's become political. It's the cultural, you know, we think it's bad, and it's just tragic. You know, Florida's had the highest deaths it's ever had in the age of vaccination. Idaho, currently, where they have 40% of their population vaccinated, really actually quite low, have just really gone into crisis mode and said, if you have COVID as an adult, you have an automatic do not resuscitate order, whatever age you are, because they're so full. And to think that they're there when in the age of vaccination and almost all, over 90% of people in hospital are unvaccinated, it's just tragic. It's really tragic.
It is. Another question for you, Christina. This is from Tanya, who first of all says thank you very much for all the work you've been doing with Independent Sage, and also would like to know about the 9-point plan. She said she read this morning and it seems entirely sensible, so I'm assuming there's zero chance of the government acting on it. Can you tell us a little bit about that 9-point plan?
Yeah, I mean, I think it is recent. It's kind of weird that sometimes people kind of talk about Independent Sage as if we're really extreme, and I'm like, we're not. It's very mainstream, and most of the time we're totally aligned with Sage and the WHO and you know, the CDC and so on. So the idea is that the vaccines are amazing, but you just need a little bit extra. And we're seeing that in Europe. Most European countries are doing kind of vaccine plus, so vaccines plus some masks plus ventilation and so on, and kind of keeping it under control. So the first thing is just to roll out vaccinations to everyone over 12. We've now started doing that, but really push to try and reach communities where it's been harder to vaccinate. So we know that there is lower coverage in ethnic minority communities and more deprived communities. And those are exactly communities that are more at risk from COVID because they're more exposed and also more underlying health conditions which make you sicker if you get it. So we have to make it really easy to get vaccinated. We have to make sure that people get paid time off work to get vaccinated, that they get paid time off work if they have side effects that mean they have to take a day off. You know, that kind of thing we have to do. We have to keep testing and also update the symptom list. We have 3 symptoms currently that mean you qualify for a PCR test, which is a temperature, continuous cough, and loss of sense of smell. Now, we know now that in the age of vaccination and in the age of Delta, those are not the most common symptoms. Like, they're just not. The most common symptoms are much more cold-like symptoms. We haven't told that to anybody. And if you have those symptoms, you can't get a test. We know that children have different symptoms. They tend to have more, like to have gastro symptoms, like diarrhea or stomach pain. And so if we're not even telling people what the symptoms are, how do we expect to kind of keep track of this disease? So that's just like a really simple thing we could do that we're not doing. Things like wastewater analysis, we've started doing it, but doing it on a much more large scale to pick up where outbreaks are. Contact tracing, we've been saying for over a year, we know that that is, the most of, we're doing mass testing of people who don't have symptoms, but we don't typically test people who've been in contact with someone who've had COVID, who have the highest risk of having it. Like, that's just crazy. And the WHO said from the beginning, you should be testing all contacts. Most other countries do that. Supporting people to stay at home if they need to isolate. I mean, these are just really basic things. One of, I think, the things which could make a big difference is kind of asking workplaces and businesses to have COVID plans around ventilation, but also around how many people are there, hygiene standards, and so on, in a way that, when you go into a restaurant, you have a hygiene standard, why not have a ventilation standard? So you can see, what is the air exchange? Do you have CO2 monitors? In Belgium, they have to display CO2 monitors in every business. And then if they're over a certain threshold, they have to act on it. Things like that. The right to work at home from possible. Sage, in their minutes last week, said that they think continued working from home has been incredibly important and actually keeping cases not going massively high this summer. And they are quite worried about everyone returning to work this autumn. So things like that, can we keep working from home where possible? Masks, and not just masks in public spaces, but the right type of mask. So many European countries now say you need what are called FFP2, which have a higher filter, which means that not only do they stop you breathing infected air on others, but they actually can protect you as the wearer. So we haven't ever really done any messaging on that in the UK. That's kind of quite a quick win. And then making those kind of masks freely available for people who need them. Better communication in general. We've had such mixed messaging on everything, and kind of having consistent messaging with the right communities. And then just finally on the international stuff, we have to try and get vaccines out to low and middle income countries. And that's not just through donation, but it's through patent waivers. So most high income countries support a patent waiver on the vaccines, which would allow other factories to start making them, including the US, including Japan. The UK and Germany are some of the only countries that are resisting this. And also technology transfer to make it really easy to make that happen. And again, that's not happening. So those are the things we could do. That's the plan.
Thank you so much. That's great. And it's interesting when you talk there about going back to work. That's a question we've got for you, Helen, from Goodwin's Law. Wants to know whether going to the Azores last week was your first work trip that you've done, and just how you felt about that, how you felt about the experience of travelling, etc.
Yeah, it was. It's the first time I've been anywhere, and I try not to fly in general. I did it. There were reasons for that. I thought it was worth this trip. So I was, and so there were also environmental concerns for me as well. I felt what was interesting was that when everyone's traveling a lot less, spaces are generally a lot, people are a lot more spread out, and we're mostly wearing masks. So everywhere outside the UK, actually, people were wearing masks more in Europe in the places I went indoors than they do in the UK, because here there are a proportion of people who don't, but in the places I was, everybody was wearing a mask indoors that I saw. I almost never saw anybody indoors anywhere in Portugal who wasn't wearing a mask, and that was quite striking. So I felt, and I was being careful, so I felt all right, because everyone was spread out and because these are big spaces. But I can see that if you increase the number of travellers, automatically you get a problem because everyone is more squished in. So I think there's a kind of catch-22 here, which is that when there are not many travellers, it's probably okay. But if it's okay, if you say that, then there are more travellers, and then maybe it becomes less okay. So it's a bit of a mixture. And when I was there, I was working mostly outdoors, so I was fine. I was out on the ocean, away from COVID. So I was just very aware of it. I am definitely not keen on indoor crowded spaces. You know, while we've been here, even in Inverness, we've only eaten outdoors, and I definitely see it's going to be interesting to see what happens when the winter comes, because in the summer, even here in Scotland, you know, you can sit outside and eat. Like last winter, I had, you know, big thick trousers and boots, and we just sat outside because that was what we did. And the British don't really have a culture of doing stuff outside. The Swedish do, for example. And I think it would be nice if we learned some of that. I would feel more comfortable if we learn, because, you know, it's just out. You need a big coat, fine. If you have a big coat, then just go outside. And so I think the real test, you know, from a non-scientific point of opinion, is that the winter, what people's behavior going into the winter. Do we dress up warm and stay outside? Or once it becomes a bit cold and a bit uncomfortable to be outside, do we go, oh, it's too cold, I'm just going to go inside and take the consequences? Because that's quite a big behavioral thing if you scale it up. And it feels to me like that might make a big difference. But because, for the point of view, the trips I've done recently, there's been few travellers, everyone's been spread out, and so I felt that it's been fine. But it does turn you into a kind of curtain twitcher, you know, that sort of stereotype of people twitching their neck curtains to watch everyone else. You do pay more attention to everyone else's behaviour, which may or may not be a good thing, I think, without being judgmental, but just to decide where to go. You know, do you go over there with a big group of people who are not wearing masks closer to them, or do you go into a big space? It's a shame that the judgment seems to be a thing. It's a shame that the judgment is necessary, but I will walk into the big open spaces.
The mask thing is interesting about other people's experience, because I think yesterday when I was traveling and so many people weren't wearing masks, I don't think it was done out of any kind of, they weren't doing it for any other reason than it's not mandated now in a lot of places, and they're seeing a government that aren't wearing them, and so they're just it's a much more casual decision. Sometimes I think we can be, you know, it is very easy to be furious, and sometimes it's just that people, it's the awareness. And I have heard it's much worse in England than in Wales and Scotland as well.
Christina, you had to go.
Yeah, well, I think with mask wearing, like, there is a lot of you do what your peers are doing. And so for me, now that it's not mandatory, I'm often, you know, in the minority, and I feel much more self-conscious, and I still wear a mask, but I wish other people were, and I wish it was the norm. And that's where I think actually having a mandate can really help, just because it takes away this kind of people judging you for wearing a mask, just as you're judging others for not wearing a mask. And then on the indoor things, like, that's where I think things like ventilation standards would really help, because I'm not going indoors to restaurants or bars at all. If I knew that they had fresh air exchange 6 times an hour or something, I would feel much, much happier about doing that. You know, and it's kind of, it would enable me to do more things as somebody who's trying to be sensible and who hasn't yet, touch wood, had COVID.
It is going to become harder, but I was thinking about this in the winter. So I'm a badminton player, which is an indoor sport, and I've been playing indoors with my coach. So that's 2 people on a great big badminton court. But club sessions, like, and those are really, like, that really makes a difference to my life, and I do not feel comfortable doing it. And that those judgments also, like, how do you weigh up the mental health benefits against the physical risk? I think a lot of people are struggling with that. But it would be great to have, because the thing that you say about ventilation, Christine, the thing is, ventilation is complicated. Actually, it's really complicated. What kind of filters, what kind of particles, what kind of air exchange, where's it coming from, all of that stuff. And that's something where you can't do all your own research for every venue. You need someone to have, like you said, established a standard. It's one of these or one of those, and you know, you need that help. And at the moment, it's so frustrating that it's not there.
I'm going to do this. We've had this question from various people, which is obviously about the vaccination for 12 to 15-year-olds. So if I could start with you, Sheena, I've seen some of the kind of daytime TV debates about this, and I think they have been, from what I've read, been very misleading in terms of the disadvantages versus the advantages. So Sheena, for people who are out there now wondering whether to get their children vaccinated or not, what would you say to them?
I would say to them the vaccines are the best way to protect your children from the effects of COVID. Initially, it was felt that children weren't necessarily getting such severe effects from COVID, but we are seeing more and more children with long COVID and side effects from having had COVID. And of course, we don't yet know what the long-term implications of having had COVID are going to be. You know, we know it's a disease that can affect the cardiovascular system, it can affect the lungs, it can affect the brain, it can affect so many things. And, you know, long COVID's a disease that we're still getting to grips with understanding and working out how we're going to be able to manage that condition. So that's not a great legacy to leave for your children. And so I'd say that the risk of that happening to your child versus the risk of some unknown thing that the vaccine might do in 50 years, which is highly improbable because we've had vaccines for years and years and years, and we haven't seen any weird effects from them, seems to me a sort of good odds. Plus, it lets the kids stay in education, lets them stay with their friends, lets them do their sport clubs, their different clubs. So there was some debate about whether or not the vaccines caused a slightly higher risk of myocarditis in children, and I think some of the data suggested it might just be boys. But I've seen a lot of discussion about how good that data actually is, and if there's some debate about how it was interpreted and in the way that they took the results. And actually just a reminder that COVID causes myocarditis. So the risk, if there is one from the vaccine, is probably again less than the risk from having the virus itself. I will definitely be vaccinating my 12 to 15-year-old. He's very happy to have the vaccine. I haven't brainwashed him, but I have talked to them about, you know, what the vaccines are doing. He doesn't want COVID. He doesn't want long COVID. He wants a normal life as much as he can. So yeah, it's difficult though, I know. And I think we need to get that information out to children. We need to get that information out to teachers, and we need to get that information out to parents and take their questions in a very open way so that they feel that their questions are being dealt with, they are being listened to, and they are not being kind of accused of being stupid or anything. Questions are good. Just we have to listen and understand what the concerns are.
Christina, would you like to add anything to that?
Yeah, so this is another area where I'm frustrated by us not paying any attention to other countries. We're pretty much the last high income country to decide to vaccinate 12 to 15-year-olds. And, you know, it's been really interesting to watch countries make that decision over the last 5 months. Canada and the US were the first in May to start doing it en masse. And so by the end of June, we'd had over 6 million teenagers in the US vaccinated. And there is a very small increased chance of myocarditis after vaccination, particularly in boys. It's something like 40 to 50 cases per million doses. But then as the summer went on, so in July, about half of Europe was vaccinating and half of them decided not to. But then evidence came through from the States that if you do get myocarditis after vaccination, it's very mild. It seems to clear up almost entirely. And more evidence was coming out that actually you're much more likely to get heart problems from COVID itself. And there was Delta. And so you could see European countries saying, okay, well, Delta means it's really hard to control in schools. We know that we're going back to school in September. We know now that it's actually mild if it happens, it's COVID. And so they kind of made the decision. So Germany made it in the middle of August. I think Norway was beginning of September. And we were still saying, oh, I'm not sure, let's wait. So the JCVI said, let's wait 6 months. I'm like, by then, you're ignoring the fact we're in a pandemic. By then, almost every child would have been exposed to getting it because we're putting them in schools. And that, I think, is what is frustrating, because now it's really good that we are offering it to teenagers. I think it does give them clinical benefit. It also benefits more widely because it reduces transmission. But we've kind of missed the chance to do it before we go back to school. And not only have we not been vaccinating teenagers, but we're one of the very few countries that isn't really doing any mitigations in schools. So, you know, the CDC and the European CDC said, you need vaccination and you need masks, you need layer protections, you need bubbles, you need all these things, because we are putting people in crowded indoor spaces. And we're not doing that either. And we have high rates of COVID. So we're the only country that's really basically been like, well, we don't care that much if kids get COVID, and I find that shocking. So that's my opinion on it.
I completely agree, and I feel that even when we have started to vaccinate, because also the sort of over 16 age group, again, it was just we're starting it far too late. you know, they're already pretty much were going back to college, and it wasn't that easy to work out how to get your kids vaccinated, because you really had to know which vaccines that they were going to be likely to get. You had to check when the vaccine clinics were open. You had to be able to get them there. Not everybody can do that. And then go through and just double check. So it wasn't straightforward. I mean, I know a lot of universities and colleges are now doing open clinics once you're at school, so you can get it done there, which is fantastic. But it all feels like we're always so late, and we're getting, you know, as a parent, you're not getting the same kind of information. Now, it's one thing me kind of having my children lateral flow regularly, but we got a letter saying there's loads and loads of cases in our kids' school, and I had no idea. It's already happening, and they've not been vaccinated yet. So it's really frustrating. It's really scary.
That not getting information seems to, because that's been happening in my son's school as well, which is no longer are you informed, when people, it seems, in the classes.
So that is, can I say that is national policy, that they've decided they're not contact tracing within schools, which I think is, again, it's basically saying we don't you're not a contact if you're a child. If you're under 18, you never have to isolate as a contact. And even if your parents have COVID, you can still go to school. And it's just this kind of like, we're not trying to stop spread in schools. That is the problem. And I think, you know, for that reason alone, we have a moral obligation to offer vaccination and protection to children. And they want it. You know, we have almost 60% of 16 and 17-year-olds now have had a first dose. It's not that people aren't keen to get that protection. So
yeah, it seems utterly crazy to or just so that, because I think for a lot of people who are working now, suddenly they're being distant from their children as well, because they're going, oh, I can't get too close, and that doesn't have a good mental effect. I think, you know, it's just, yeah, it's there's a lot of ridiculous things going on. I'm sorry we haven't had time. There's so many more questions to deal with, and anyone watching, if you would like us to do a follow-up, because we've still got about 40 questions here, and we could probably do it in the next couple of weeks. So if you would like to, if we can get, if either Christina or Sheena would like to come back as well, and if not, we'll find other people as well. They are very good, I can tell you that, and it's really worth following them as well on Twitter and social media to see the stuff that they're putting out. This is just an interesting question to me, for Christina, for you. This is from Zahid, who says, but actually, no, I'm not going to do Zahid's question. There's another one I'm going to get. I'm sorry, Zahid. We are going to do your question one week, but I wanted to ask this question from Claudia for you, Sheena. And this is about how worried should we be, or shouldn't we be, about new mutations emerging in animals. I read this week that a dozen gorillas in San Diego tested positive. Are we vaccinating animals too? Now, it's very, because we did a thing recently about people working in the field with primates who aren't able to go in the field at the moment and do their research. But this is an interesting thing about how these mutations might work.
It's a really interesting question, and actually, so we do know, of course, that a lot of coronaviruses are kind of native viruses in animals, and particularly the beta coronaviruses are often found in bats. There's been a lot of debate about the origin of COVID-19, the virus that causes COVID-19, and some really interesting stuff's just coming out recently that's really firming up this natural origin theory. And they're starting to wonder if actually there was multiple infection events around Wuhan, from animals to humans. There's several species of animals that are in these sort of live markets that are able to carry COVID and potentially infect it. So we know that viruses can cross over to humans. So yes, we do know that happens. That is always a concern, and we've seen several examples of what we call these zoonotic infections over the years. So SARS was also an example of that, and I guess, well, Ebola originally was an example of that as well. HIV is also an example of a zoonotic infection, and some of the types of flu that we get. In terms of what's happening with animals at the moment, to my knowledge, we are not vaccinating them. We haven't got the vaccines for them. I think there's been quite a bit of concern because there's been descriptions of them in our pets. Cats and dogs, I think, can carry it. But there have been, to my knowledge, no descriptions of it passing from cats and dogs to humans as of yet, but there has been advice to be careful if you have COVID around your pet so that you don't give it to your pet. I think it's something that we just have to be vigilant about, and it's a really, really difficult one. And you know, there's some really fantastic surveillance that goes on constantly trying to monitor and predict which will be the next kind of big infections, which will be the next infections that will cross over. But with things like climate change, with things like the encroachment we're constantly having on kind of, you know, sort of wildlife's areas, we're going to get these spillovers. You know, animals have less natural places to go. They're mixing more with humans. It, unfortunately, is inevitable. I don't know if that was reassuring or not, and I don't know if Christina's got something to add.
If it's time, could I just ask because I was looking at the headlines that have been in the last couple of days, and not all of them have actually been able to see the stories. And I saw that the Telegraph had a headline, I think on Thursday, which is something that I know nothing about. So I just want to ask you, Christine. There was a headline that said, "Why didn't doctors listen to women about the link between COVID vaccines and periods?" Do you know what this was all about?
I know a bit about what it was about, but I have to say it's not something I can talk about with much expertise. But basically, women, young adult women, were reporting after vaccination that it seemed like it changed their menstrual cycle, and they kind of linked that to the vaccine. And then people were saying, no, that isn't the vaccine, but now it does seem that potentially it might be. But I can't tell you any more than that, because honestly I haven't been following it, and I don't know anything more about that. So I don't know if Sheena knows something about it.
Sheena?
I think it was something that started anecdotal, and lots of people were reporting it. And I think when they had enough volume of people, it's something that they are now seriously looking into to see whether it is a real thing. I still don't think it's been established whether it's definitively a vaccine effect or whether it's something else, but I think it is actually being investigated. And that's the joy of reporting any side effects, whether or not they are actually caused by the vaccine, onto that kind of reporting system, because it enables everybody to look for trends, to look for things that are happening, so that they can research them properly and see whether this is just correlation or causation. So this is, I believe, being established now, but we don't know if it is true causation. I think
it's probably worth adding that the reason that this was picked up by the press, although I wouldn't have expected the Telegraph necessarily to be at the head of this, is the long held, well, it's not just a suspicion, it's demonstrated truth that women's diseases are ignored, that doctors have not listened to women for decades, centuries. And so I think that this is actually a very complicated issue to discuss, because there's two things mixed up here. There is a very long history of women's pain not being taken seriously, and you know, that they are complications that come with having menstrual cycles, right? Weird things happen, and you know, medical studies have excluded them because that's complicated. So I think there's two things. There's this history which is now being uncovered. There's a book that's just come out, I think it's called Unwell Women, which talks about this history. So there's a sensitivity around that, I think, that women are saying, no, you need to listen to us. But as Sheena says, it is at this point anecdotal. So of course you have to do what is being done, which is the proper studies. But it's a complicated thing to discuss, because there is this very clear history of not doing things properly when it comes to women's medicine, overlaid with not every anecdote, you know, they're anecdotes, they're not data, and there's a difference between those two things.
Yeah, I mean, can I just say one thing about periods? We're on it. I'm period, and we're hoping to make it into a much bigger project on the grounds that it is ignored, and something. And we're just looking at initial data, and there's something like 20% of women's visits to GPs in their reproductive years are through problems with their periods. And we accept it as a society. We accept that people have a lot of pain, or they have heavy menstrual bleeding that disrupts their life. And because it's not life-threatening, because it resolves every month for 2 weeks or 3 weeks, we don't care. And actually, it's a massive, massive impact on half of our population's lives. And it's not acceptable that we're not researching it.
And it has to be said that lots of our immune cells have receptors for hormones. So, hormones that change, of course, during the menstrual cycle will have an impact on how immune cells behave and function. And it's a really interesting area of research. We understand that females and males do not have the same immune response at all, and we know that women have a completely different immune response during different stages of pregnancy. I think there's so much more we could learn about it, but yes, it's definitely a very important area, and it's a very probably not studied enough. Yeah, thanks for doing it.
Yeah, thank you all very much for joining us. As I said, do go and I'm sure many of you already go follow Helen on social media, but also Christina and Sheena, because you will find a lot of interesting things being tweeted by them and from reliable sources as well. And in these times, it's very, very useful as well to see that. So thank you very much, all of you, for joining us this Sunday. And thank you very much to our producer, Trent. As I said at the beginning as well, if you can support us via Patreon, that is absolutely fantastic. It helps us keep doing all of these things. Patreon.com/Cosmic Shambles. And as I said, the latest Tips for Existence is with Carolyn Porco. And before that was one with Eddie Glaude, who is also really fascinating individual. And we had some lovely feedback about that as well. Have a lovely Sunday, and hopefully we will see you next week. Bye-bye.
Bye.